product rule. The product rule is known as d by dx of f of x times g of x is equal to f of x times the derivative of g of x plus the derivative of x of f of x times g of x. So as this is the rule, it's interesting to see how it's actually derived from the first principles. So if we try to write the limit definition for it, now d by dx of f of x times g of x is equal to the limit as delta x approaches 0 of we take the whole function as it is, here it is, and replace every x with x plus delta x. So it's gonna look like f of x plus delta x times g of x plus delta x minus the f of x, the function, all of it, all together in x. So it's gonna be f of x, g of x. And here our function is the multiplication of these two functions. So that's why we're putting everything as the first term here, and here is the second term. And that is divided by delta x. Then there is a well-chosen term that is going to be added and also subtracted from the numerator so that we're adding actually 0. That well-chosen term is f of x plus delta x times g of x. All right, so right now I'm just going to put it and see how we're going to redistribute the numerator and how it would help us turn out to be. So I'm going to write the numerator here along with this added term. So it's going to be f of x plus delta x, g of x plus delta x, minus our term f of x plus delta x times g of x, also plus the same term f of x plus delta x. So we're basically adding 0 minus f of x g of x. So right now we can see that we can take f of x as a common parameter here from the first two terms. So it's gonna be f of x plus delta x. This is the term that I'm taking as a common factor. I'm going to have g of x plus delta x minus g of x. And these, the first terms, how they ended up looking like, the first two terms. Then from the second two terms, I can take g of x as a common factor. So it's gonna be plus g of x as a common factor, and we're gonna end up with f of x plus delta x minus f of x. So now let's look at it. This whole term here, let's remember that it's divided by delta x. And this whole term here is divided by delta x. So we can write that the limit as delta x is approaching 0 is equal to this big first term here, but I'm going to write it as f of x plus delta x times delta x here, and up is g of x plus delta x minus g of x. So this is actually the derivative of the function g, right? And then the second term is gonna put it as plus g of x times, here we have the delta x, f of x plus delta x minus f of x. So that part here is the derivative of the function f. So let's write what we have here. It's equal to f of x plus delta x times g of x, the derivative, plus g of x times the derivative of the function f. So the only remaining part here that we need to simplify is here, f of x plus delta x. Actually, because the function f has a derivative, then it must be continuous. So the limit exists. So we can say limit as delta x approaches 0 of f x plus delta x is equal to the limit of, let's say, u approaching s x f of u, and that is going to be equal to f of x. So we can actually simplify it as f of x times the derivative of the function g plus g of x times the derivative of the function f. And this is the proof of the product rule.